All right, we have module 20 here, which again, it starts with 5 topics that are from previous modules. So if you need any help with those first 5 there, they're from module 16 and 17. They're kind of getting you ready for inverses because logs and exponentials are inverses of each other. So, but let's go ahead and get started. The first one is using properties of logarithms to evaluate expressions. So they use 2 properties, well, actually 3 properties here that we've seen before, where if you have a times log base b of c, that can be written as log base b of c to the a power. Okay, and then we also have log base b of a plus log base b of c is log base b of a times c. And if it's subtraction, then that would be log base b of a over c. Okay, so we're going to use some of those properties to simplify these expressions. So for example, the first one is 2 log base 6 of 3 plus log base 6 of 4. And we're supposed to simplify that. Okay, so neither of those logs are something we could calculate right now. Okay, we know, again, some of the ones that we do know, log base 6 of 1 would be 0 because 6 to the 0 is 1. Log base 6 of 6 is 1 because 6 to the 1 is 6. Log base 6 of 36 is 2 because 6 squared is 36. Log base 6 of 216, I believe. I guess 6 cubed is 216. Yeah. Because 6, oops, I wrote something wrong up there. 6 to the 3rd is 216. I swapped them up here. Hopefully you caught that. 6 squared. Okay, and so on. So we can't do log base 6 of 3. Log base 6, log base 6 of negative 1 is 1/6. Remember, because, got those switched too. Hold on. 6 to the negative 1 is 1/6, and so on. Okay, so we don't have anything for 3 or 4. All right, so we use our properties that are listed up here. So we can slap that 2 on the 3. So log base 6 of 3 squared, which is 9, and log base 6 of 4. Okay, and then we can use that second property, that's log base 6 of 9 times 4, which is 36. Okay, so we multiplied, here this is log base 6 of 3 squared, and then we get this by doing the 9 times 4. Okay, and that we can do, since 6 squared is 36, log base 6 of 36 is 2 for your final answer. Okay, another one. A little bit different here. We want to evaluate natural log of e to the 5th minus the natural log of e to the 12th. Okay, so we're going to do the opposite of what we did in the first one. We're going to bring those powers down. Okay, and this is just like doing 5x minus 12x. Okay, 5 natural log of e minus 12 natural log of e, that's negative 7 natural log of e. Okay, and then we also know the natural log of e is 1 because e to the first power is e. So this is the same as negative 7 times 1. So negative 7 is your final answer there. Okay, let me see if there's any sort of different one that they might give you. These look pretty standard. But this should be enough for you here. Okay, let's get another one here. Next one is solving an exponential equation by finding common bases with linear exponents. That's a lot. Okay, so we've got a problem like 32x plus 5 equals 64. Okay, notice in the title they want common bases. Okay, so that's going to mean that your 32 and your 64 can both be written with the same base to a power. Okay, so you want to think about some of your, we don't have to get too crazy here, but if we're talking about base 2, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, and look at that, 2 to the 6th is 64. Okay, so both 32 and 64 can be written with the same base. We can write some of these other ones out if we have 3. 3 to the 0 is 1, 3 to the 1st is 3, 3 squared, 3 cubed, 3 to the 4th, 3 to the 5th. They probably won't get too much farther than that. Okay. And we don't have to do 4 because 4 would be base 2. So if anything was divisible by 4, we could probably put it in base 2, but we'll stick with those for now. So what you're going to do is you're going to rewrite your 32 is 2 to the 5th. And then your 64 is 2 to the 6th. Okay? And then you use your power of your power rule. Remember that b to the a to the c is b to the ac. Okay, so we can write this as 2 to the 5 times x plus 5 equals 2 to the 6. And then that means that 5 times x plus 5 has to equal 6. Okay, so we can simplify that now. 5x plus 25 is 6, which makes 5x negative 19. So x is negative 19 over 5. Okay, I can find another one. Let's see if there's any that are bases other than 2. Here we go. Okay, so another one, 81 equals 27 to the x plus 1. Okay, so we showed over here that 81 and 27 are both powers of 3. So 3 to the 4th for 81, 3 cubed for 27. Okay, so then that means that 4 is 3 times x plus 1. So 4 is 3x plus 3. So 1 is 3x, and x is 1/3. Okay, another way you can solve this too is a lot of you might decide to divide by 3 first, and then subtract the 1. So that's 4/3 minus 3/3 to get your 1/3. Okay, next one. We have solving an exponential equation by using logarithms with decimal answers. That means you're going to get to use a calculator here. Basic. Okay, so we're going to solve for x. Okay. So let me just look real quick at how they have you do it. Okay. What we do when you're trying to solve, you might remember this from Algebra 2, anytime you are trying to solve for a variable and it's in the exponent, you take the log of both sides. Okay, and you could do the natural log or you could do the log base 10. The reason you do those is because that's what's on your calculator. So if we do log base 10, right, if I don't write it, it means base 10 of each side, okay, then that allows me to take that 7x out front. Okay. And now I can solve for x. So 7x would be log 2 over log 6. And so x, I'll do that on my calculator. Okay, I'll take log 2 divided by log 6, and then I'll divide that by 7. Okay, and you should get 0.06. Okay. All right. We can do one more of those just in case you need one. The next one is 11 to the negative 9y equals 15. So log both sides. The negative 9y then can come out front. Then we can divide by log 11, and we can divide by negative 9. You can also do it all in one step. Instead of dividing by the log first and then the other number, you can just write this whole thing as log of 15 over negative 9 log 11. Okay, so on your calculator, you would do the log of 15 divided by negative 9 log 11. Okay, and as a decimal, looks like they're having you round to the 100ths, so negative 0.13. All right, next one. Oop, lost my spot just a second. Same thing, but just using natural logarithms. And you would do this. Actually, in more advanced classes, we pretty much always use natural log. But in this case, we want to because there's a base of e. So here, if I go back up here, if I had taken the natural log of both sides, and you can test it on your calculator, instead of log base 10, if we had done log base e, we'd get the same answer. Just how they work out. Okay, so a lot of times in like calculus, we don't do log base 10, we just do log base e. But for this next topic, there's actually an e in there, so you want to do log base e. So we have e to the y minus 7 equals 4. Okay, so when you see that e, take the natural log of both sides instead of the log of both sides. Okay, so then you can bring that y minus 7 out front. And then the natural log of e is 1. So y minus 7 is the natural log of 4. So y will be 7 plus the natural log of 4. And using your calculator, 8.386. Okay. Another one, which is too similar to this one. Let me get one that's at least a little bit different. They're not going to give you too many that are different, it looks like. E to the x plus 7 equals 4. Natural log both sides. Then that x plus 7 comes out front, and our natural log of e is just 1. So x will be the natural log of 4 minus 7, which should be about negative 5.613. All right. Next one, an advanced one. So same topic, but an advanced. So solving an exponential equation by using logarithms. Decimal answers. Advanced. And it's just maybe a couple more steps here. You'll be okay. They have an x on both sides, I think is what makes it advanced. So we have 9 to the negative x minus 8 equals 5 to the 9x. Okay, so we're going to take the log of both sides. Again, feel free to take natural log of both sides. I'll do this one. with natural log? All the same rules apply, and you'll still get the same answer. Okay, so this allows me to put the negative x minus 8 out front. Okay, so now, if you remember, when you have x's on both sides, you want to try to group them together on the same side. So we're going to distribute this left hand negative x times the natural log of 9 minus 8 times the natural log of 9 equals 9x times the natural log of 5. Okay, and then what we're going to do is get the x's on the left-hand side or the right-hand side, doesn't matter, and then the 8 natural log of 9 on the other side. So I'm going to add 8 natural log of 9, and I'm going to subtract 9x natural log of 5. Okay, so that will give me negative x natural log of 9 minus 9x natural log of 5 equals 8 natural log of 9. Okay, factor out an x, and I'm left with negative natural log of 9 minus 9 natural log of 5. Okay, and then I can just divide. So x will be 8 natural log of 9 over negative natural log of 9 minus 9 natural log of 5. Go ahead and do that on your calculator. Be really careful with your parentheses. We should get about negative 1.0536. Okay, we can do another one of those. They give you 11 to the negative 6x equals 16 to the negative x minus 4. Okay, so again, the x, the variable is in the exponent, which means you're going to have to use logs. All right, in the previous example, I did natural log. Here, I'll just do regular log. Okay, so I'll take the log of both sides, which allows me to bring the exponent out front. Okay, I'm going to distribute. So here I have my negative 6x log 11 equals negative x log 16 minus 4 log 16. I'll get my x's on the same side, so I'm going to add, excuse me, add that x log 16 to the left-hand side. Factor out my x. And then my last step will be to divide. Okay, and go ahead and use your calculator for that. And we should get about, oh, I just lost the answer there. Hold on. 0.9548. All righty. Let's get to our next one. We have solving an exponential equation by using logarithms. Exact answers in logarithmic form. Okay, so no calculators. When they say exact answer, that means no calculators. We basically just kind of leave it as we would before we used your calculator. So honestly, it's just the same problem as before, but you don't plug it into your calculator. So you just leave it. So like this one, we would just leave as that. Okay, and that's it. You can use it, and they do give you the option. You can do base E or base 10. So they're just looking for one of those answers. Okay. I don't think there's any weird little things that they want you to do here. Yeah. So there you go. It's the same problem, just one less step. Okay. I'll do one anyways, but we have 17x to the negative 9 equals 6 to the 10x. Log or natural log both sides. I'll do natural log on this one, and I'm just going to pull the x minus 9 out front right away and the 10x out front right away. Distribute. Get your x's on one side. Let's do factor out an x. And divide. And that is it. Okay. And you will notice too, one thing that some kids would do here, you see 3 terms, right? 1 in the numerator and 2 in the denominator. 2 of those terms are negative, including the one in the numerator. So one thing that you can do, and it's optional, is multiply by negative 1 over negative 1. Okay, so then you'd have 9 natural log of 17. So we have a positive numerator, okay? And then the 10 natural log of 6 would be the negative part, and the natural log of 17 would be positive. So you can write it as natural log of 17 minus 10 natural log of 6. Okay, but Alex will take either one. Again, they'll also take it if it's base 10. We'll do that too. Okay, all right, next one. Finding the rate or time in a word problem on continuous exponential growth or decay. PERT. You should be thinking that right away. Okay, so continuous growth, A equals P E to the RT. Okay, A is the amount at time T. P, a lot of time when we're talking about finances, P is the principal. P is just kind of your initial value at time 0. Okay, R is your rate. And an example on that, if your rate is 2%, then it would be 0.02. Okay, and then T is your time. All right, so this question says the number of bacteria in a certain population increases according to a continuous exponential growth model with a growth rate parameter of 6.7% per hour. How many hours does it take for the sample to double? Okay, so for this one, you might think that you're missing something, okay? Because really, all we have is that r would be 0.067. We're supposed to solve for t, but what are a and p? Okay, and here's the thing, it doesn't matter, just as long as a is twice p. Okay, so obviously the easiest thing to do would make a be 2 and p be 1. So when we have our a equals pe to the rt, we'll have 2 equals 1 e to the 0.067t. Okay, and then we're going to try to solve for t. Well, the first thing that you would do is divide by 1. Right, if that was a number, so you would have 2 over 1 equals e to the 0.067t, or obviously 2 is e to the 0.067t. Okay, and it doesn't matter because, like, if I made a be 72 and p be 36, a is double p, right? So I could do 72 equals 36 e to the 0.067t. My first step is going to be dividing by 36. So I'm still going to get 2 is e to the 0.067t. Okay, they're just kind of dummy, like dummy placeholders there. It doesn't matter, okay, because the first step, it's a ratio of them anyways. All right. So then we know that to solve this, you guys got that, right? We need to do the natural log of both sides. So the natural log of 2 would be the natural log of e to the 0.067t. We choose natural log because it's base e, okay? So we don't really have the choice here. We want to use natural log. So natural log of 2 will be 0.067t times the natural log of e. When you bring that exponent out front, that's just 1. So then we'll solve for t, and t will be the natural log of 2 over 0.067. Okay, that's about 10.35 hours. And you can always check too. Go back to your original equation, plug in your value for t, and just make sure that you get 2 when you do e to that power. Okay, let me see if there's one that's different than this, because they say finding the rate or time. So we found the time. Rate's going to be similar. They're both exponents. Okay. All right, so I'm just going to use a different color here because it's pretty much the same setup. The number of bacteria in a certain population increases according to a continuous exponential growth model. So let's go with the same. I don't want to have to write all that out here. Okay. And they tell you we have a sample of 1,800 bacteria selected from this population, reaches a size of 1,984 bacteria in 2 hours. Okay, find the growth rate. So we have A equals PE to the RT. Okay, we started with 1,800, and after 2 hours, we were at 1,984. Okay, so this is another one too. They could have said it doubled, and you would use 2 and 1. Okay, but they gave us more specific values here. So we're going to do 1,984 divided by 1,800, and I'm just going to leave that. Because you don't want to round too much on your calculator. So hold off on any sort of punching this in until you're at the end. Okay, like over here, you would want to use your calculator to do the natural log of 2, hit enter, or do it all in one line divided by 0.067. So you get your nice exact answer. Okay, we're going to take the natural log on both sides here. So natural log of 1984 over 1,800, and again, just leave it, is going to be 2r times the natural log of e, which is 1. Okay, so r would be the natural log of 1984 over 1,800. So do that on your calculator first and then divide it by 2. Okay, and you get 0.04866 and on. Alex wants the decimal. Okay, so multiply that by 100 to get 4.87%. Okay. All right. Got a few more from section 4.6 to do. Next one we have is finding the initial amount and rate of change given an exponential function. Okay. So for this one, okay. This one says, suppose that the dollar value V of t, I don't know why they use, I guess V for value, of a certain car that is t years old is given by V of t equals 29,900, 1.24 to the t. Okay. So if you remember this one, you probably saw it a little bit different when you did it in like Algebra 2. We still have your amount after time t, okay, just like the previous one, equals some initial value. It's not continuous growth though. So it's 1 plus r to the t. It's like it's your compound interest one, okay? So p is the initial value. R is the rate. T is time. A is the amount after time t. Okay. So this question, the things that it asks, there's a couple ways to think about those answers. So we're going to start with the first thing it asks is find the initial value of the car. So there's two ways to do this. You can take your equation, the initial value, that would be when t is 0. So V of 0 is 29,900 times 1.24 to the 0. 1.24 to the 0 power, anything to the 0 power is 1. So your answer there is 29,900. Okay, but that's work that you don't need to do because if you understand the structure of these equations, that number out front here is the initial value every single time. Okay. For part B, it asks, is this growth or decay? Okay, well, our rate, since we have 1.24 in the parentheses, that's 1 plus the rate. So your rate is 24%. Okay, so that's growth. And the easy way to do that is just if that number in the parentheses there is greater than 0, or sorry, if it's greater than 1, we have growth. If it's less than 1, we have decay. Okay, if it's less than 1, that means that R would have to be negative. All right, and then so we have growth, and then C asks for the rate. So our rate is 24%. Okay, so they seem scary, but they're not. They're really just taking apart the equation, knowing the pieces of the equation there. Okay, and those look like they're going to be pretty similar to each other. All right. Two more left. The next one is finding the time given an exponential function with base e that models a real-world situation. Okay, so this one we have Ahmad places a bottle of water inside a cooler. As the water cools, its temperature, C of T in degrees Celsius, is given by the following function. So C of T equals 6 plus 12e to the negative 0.04 t. Okay, so again, C of T is temperature, and T is time. Okay, and they say the time is in minutes. Okay, all right, and then it says he wants to drink the water when C of T, the temperature, is 14 degrees Celsius. Okay, it says how many minutes should he leave it in the cooler? All right. Okay, and these are all going to be finding time. All right, so we're going to do 14 is 6 plus 12 e to the negative 0.04 t. And we are going to solve for t. So the first thing we want to do is get that 6 out of there. So subtract 6 from both sides. And then we'll divide by 12. Okay, and these you're going to be able to use a calculator for, I think. Yeah. Okay, so now we want to take the natural log of both sides because our base is e. I'm just going to leave that as 8/12 since I'm going to put it in a calculator anyways. Might as well not make a mistake reducing a fraction, right, if I'm just going to use my calculator to get there. So negative 0.04 t times the natural log of e, right? If you take the natural log of that side, I can bring the exponent out front, and the natural log of e is 1. Okay, so that t will equal the natural log of 8/12 over negative 0.04. I'll punch that in my calculator. I get 10.1. It says round it to the nearest 10, so 10.1 minutes. Okay, and I'm going to guess those are all structured pretty similarly. When I look at those problems, looks like it to me. Okay, they do have one where they just don't have the 6 out front, so don't let that throw you off. Okay, then the first step would be to divide by 12. So let me know if you do need help with one like that, though. All right, because now we're on to the last one. This one is finding half-life or doubling time. Okay. So this one says the amount of money. Let me check something quick. Invested in a certain account increases according to the following function. Okay, so we have y is y. This little 0 there, that means why not. Spelt, I should make sure I get the spelling right. It's not why not, like why can't I do that? Yeah. I'm going to get the right spelling because I can't remember if it's N-A-U-G-H-T or N-O-U-G-H-T. I think it's A. Yeah. Okay, so this is why not. Not is like a fancy word for zero. Okay, so it's your initial y value. Just being fancy on Alex. Okay, and then e to the 0.015 t. Okay, so y is the amount. Y naught is the initial amount. And then t is time. Okay, and they want to know after how many years will it double. So this is very similar to what you already did, right? It's very similar one where I said it doesn't really matter. Just use 2 and 1, e to the 0.015 t. That's it. Okay, so I mean, you've done this problem, right? So 2 equals e to the 0.015 t. We'll take the natural log of 2. We'll take the natural log of that e to that power, which allows us to put that power out front. And the natural log of e is 1. So t is the natural log of 2 over 0.015, which is about 46.2. Okay? And that was finding the doubling time. They also said we're going to find the half-life. Let me find one example like that for you. Okay. So the last example of this module, we have a radioactive substance. So half-life, I'm sure you've had this in biology, chemistry. Half-life, we know the half-life of certain substances, so we can figure out the age of it. Okay, so we have a certain substance. The half-life or decays according to this function. Okay. And same thing, where y is the amount there is presently, y naught is the initial amount, and t, they say, is measured in days. So it says find the half-life. Okay, so we want to know when we have half of what we started with. Not double is in the previous one, but half. Okay, so we can get rid of that 1. Natural log of both sides. Natural log of e is 1, and so we'll just divide by that negative 0.019. Okay, so natural log of 1/2 divided by negative 0.019, and we get about 36.5 days. Okay, and that is it for Module 20. Good news is Module 21 has only 4 topics, and we're done.